Good morning, grade 12s. I'm Mr. Khadebe from Society High School in Bloemfontein. I'm here today to present to you Geomorphology in preparation for the final examination that will be written on the 3rd of December 2020. We have seen how we did perform in September examination, which is a trial examination. So we are just going to go through, especially some of the concepts in geomorphology. We'll go through the concepts that are very important, that most of the learners didn't perform well in the trial examination. I'll start first with the concepts of geomorphology, which are very important. So remember, in the examination, every question when it starts with multiple choice of 15 marks is 7 and 8, which is 15 marks. So every time most of the concepts are included in the short objective questions. So in geomorphology, if you look at the important concept, the first one is a drainage. What is a drainage? It's a removal of water from one place to another. So when water is moving from one place to another, it's a drainage. And then drainage basin, it's a total area, the whole area that is drained by a river and its tributaries. A river system, a main river, and its tributaries collectively. Drainage patterns, a surface pattern formed by a river and its tributaries. Base level, the lowest level to which a river can erode. Watershed, the high-lying area, we separate the two drainage basins. And interfluve, the high-lying area separating the streams of the same drainage basin. Another one is a river source, where a river starts. Confluence, where two rivers meet or join each other. The other concept is the river mouth, a point where the river enters the sea and the ocean. Tributary, smaller river that feeds into a large river. Catchment area, an area where a river gets its source of water. Infiltration, where water seeps under the land surface. Groundwater, water below the surface of the earth. Drainage basin, a total number of streams in the area of a drainage basin. Impermeable, hard rock that does not allow water to penetrate or pass through. And then the last one there, it's a permeable, which is a soft or porous rock that allows water to pass through. Now, by demonstrating some of the concepts there, if you look here in geomorphology, we look at one thing. We're only going to talk about one thing here, which is water. Where do you get water? From rain, from precipitation. Immediately when that particular water reaches the earth, especially if the earth is dry, what will happen to that particular water? That water will infiltrate. It will infiltrate. Immediately when that particular water infiltrates, now it is under the earth surface. We call it what? We call it a ground water, or what? Or underground water. Call it groundwater or underground water, because that water has been what? Infiltrated under the land surface. Now, immediately that particular water is underground, then that is where now we say the top part of that particular water, we call it the water table. The top part of it, we call it what? A water table. The water table is the top part of groundwater. Remember, immediately when that particular water infiltrates underground, then we call it groundwater, and then the level in which that particular water reaches, then we say it's what? It's a water table. Now, remember this water, whether that particular water is underground or that particular water is on the surface, it is continuously flowing. So that's when now we'll talk about also the types of what? Types of runoff. So we're having a direct surface runoff, and also we're having indirect surface runoff. Indirect when the water flows under the land surface, and then in terms of the direct surface runoff, is when the water flows. When the water flows on top of the land surface. That is where we say it's a what? It's a direct surface runoff. So this one is indirect runoff. It's indirect runoff. And then this one is the direct runoff. Now, immediately when the water starts to infiltrate underground, if that particular water reaches the certain level, or if the land is full of water, then we'll talk about saturation. Once the land is full of water, that water will flow. That water will flow on top of the surface, on top of the land surface. This water will do what? Will flow on top of the land surface. Immediately when that particular water flows on top of the land surface, then it creates what? It forms rivers. Then we'll go to the types of rivers that we all know. Now, we're having different types of rivers. Types of rivers. We're having 4 types of rivers. River number 1, number 2, number 3. If you look here, so now we're having 4 types of rivers. The first one over here is a permanent river. It's a permanent river. That means that this particular river flows throughout the year. Or they call it perennial river. Perennial river. And then the second one, it's a periodic river. Periodic river, or what? They call it a seasonal river. This river flows only during rainy season. And then the third one, we're having episodic river. So this river flows only after heavy rainfall. So after heavy rainfall, this particular river will flow. Permanent river, it flows throughout the year. Why? Because it is in contact with the groundwater. Or you can say again here, the permanent river flows throughout, this river flows throughout the year. Why? Because the water table is above the riverbed. That's why it flows throughout the year. Seasonal river, this river will only flow during rainy season. So that means if it is during dry season, this particular river won't flow. And an episodic river, this river will flow only after heavy rainfall. And then the last one is exotic river. Exotic river, it's like a permanent river. It's also a permanent river. But the only difference here is this particular river, it starts from or get the water from the east or from the wet regions. Obviously in South Africa, our wet region is on the eastern side. So this is my wet region on the eastern side. So this river will flow from the wet region and pass through the dry region. Remember on the western side, remember that's where we get deserts. So this particular river will flow from the wet regions and pass through the dry regions. So we call it what? Exotic river. One of the examples of the exotic river in South Africa, it's the Orange River. It's an orange river in South Africa. So these are the 4 types of rivers. So we're having the first one, which is a permanent river. We said permanent river, it flows throughout the year. Why is it flowing throughout the year? Because it is in contact with the groundwater. The second one is an episodic river or seasonal river. Why is it a seasonal river? Because it flows only during wet season. The third one is episodic river. Why is it episodic river? Because it only flows in episode. Only after heavy rainfall, this particular river will flow. Exotic river is like a permanent river, but the only difference is this one, it gets water from the wet region and then it will pass through the dry region. Doesn't mean that when it passes through the dry region, this particular river will stop to flow. No. As long as it's still getting the supply of water from the wet region, it will pass through the dry region and go to the west. So this is our west here, and then the wet region is the eastern side of the country. So these are the types of rivers. Now, if you look at other concept here, we're having also a drainage basin. Drainage basin is the total number of streams in the area of a drainage basin, in an area of a drainage basin. How many streams are there? Number of streams in that particular area. Because now if you look here at this particular sketch here, if you check here, we're having so many streams here. So now we ask ourselves, why do we have this total number of streams in this particular area? As compared, we're having many streams in a certain area, but in other areas we don't have this number of streams. So we'll go straight to the factors influencing surface runoff and infiltration and also drainage basin. So if you look at this, then you'll be able to understand the issue of drainage density. Now, if you look there, we're having examples there, types of rainfall, vegetation cover, a gradient of the slope, soil moisture, and also underlying rock. Now, if we start with the type of rainfall, if you look here, type of rainfall, we are saying now we're having a soft rock, a soft rain. So immediately when we're having a soft rain, that simply means now that the soil will be able to absorb water. Then we'll be having what? Less surface runoff. We'll have less surface runoff. Now, let's demonstrate that. That means we're having streams here. This is the first streams, and then we're having, so here we're having a low drainage basin. No, drainage density. And then this side we're having medium drainage density, and then this side we are having high drainage density, But in most cases, then you'll see we'll only use the first one, A, and also this is going to be B and also C. But most of the time, you see we don't use this one. We're only using A and B. Low drainage density and also what? And also high drainage density. So that means now we try to check whether what happened here. Why we're having small streams here? Number of streams here, they are small as compared to number of streams over here in the high drainage density. What caused that? So that means if you go back, then we'll see that. That means if we're having a type of a rain, then we'll be having a type of a rain, then we'll say, if we are having a type of rainfall, then we say it's a soft rain. And then the other one is it's a heavy rain. So that means now, if we're having soft rain, then the soil will be able to absorb water. There won't be streams. But then if we're having heavy rainfall, then that's when there will be many streams. So that means soft rain is associated with a low drainage density. But heavy rain is associated with what? With high drainage density. So that's how it is. So we're trying to understand why here we're having small streams, or number of streams here is less as compared to number of streams at sea. So here we're having low drainage density, here we're having high drainage density. So here we're having types of rain. We're having soft rain and a heavy rain. So a soft rain is associated with what? It's associated with a low drainage density. Why? Because now, remember, if we're having a soft rain, it gives soil an opportunity to absorb that rain. But then in terms of this one, then doesn't give heavy rainfall, the water won't be, the soil won't be able to absorb that particular rain. So that's why then we having more streams here as compared to A. So A, less streams because of the soft rain, there's more absorption or there's more infiltration over here. More infiltration, and also there's more infiltration over here, but less runoff. But over here, there's what? There's less infiltration and more surface runoff over here. I hope learners, grade 12s, you are still following me there. And then the second one, the second example then will be of the vegetation cover. Will be vegetation cover. So in the vegetation cover, that is where also we'll be also looking at it's either the vegetation is high, or the vegetation is low. Or less, let's say less. High or less. So that means if the vegetation is high, then obviously it will help to do what? To absorb water. But if there's less vegetation cover on the surface or on the land surface, then obviously what will happen over here? So what will happen here is there will be more surface runoff and also less infiltration. So over here there will be what? More infiltration, and then over here there will be less infiltration. So that simply means what will happen over here? Then if we're having more infiltration, then that simply means that there will be what? There will be less surface runoff over here. But over here, in terms of the less one, if we're having less infiltration, then that simply means what will happen on the surface? There will be more surface runoff. My dear learners, I hope you are following me. And then the other one, if you look at the other examples, it's a gradient. Let's do the last example, which is a gradient. Gradient, well, it's either the gradient is gentle or the gradient is steep. So if the gradient is gentle, that simply means now there will be what? More infiltration. More infiltration, and also there will be what? If there is more infiltration, what will happen? There will be less runoff. Steep, if the gradient is steep, then we'll say there will be what? There will be less infiltration, and then there will be what? More runoff, surface runoff. There will be more surface runoff. So that simply means now, if you look at the gradient over here, this one, example of a gradient, then we are saying if the gradient is gentle, there will be more infiltration, and if the gradient is steep, there will be less infiltration. So what will happen to drainage density? Drainage density. Let's look at drainage density. So if the gradient is gentle, then there's more infiltration and less runoff. That simply means what will happen here? There will be less streams on the surface. There will be less streams on the surface. Why? Because most of the water has been infiltrated under the land surface. And in terms of this one is for gentle. And then in terms of the steep one, there will be more surface runoff. So that means now, in terms of this one, we'll be having more streams. That means we're having high drainage density, and then over here we'll be having low drainage density. So this one's for steep, because most of the water here is not infiltrated, so it runs on the, or it flows on top of the surface. That is where now there's more what? There's more streams on the land surface as compared to the first one. The first one, obviously, this one there are less streams over here. Why? Because most of the water has been what? Has been infiltrated. That is why we're having less streams over there. And then the same ones, if you go back a bit and look at the types of rainfall, in the soft rain, in terms of drainage density, high, low drainage density or high, then we'll say here we're having a soft rain. So immediately when we're having a soft rain, we said soft rain is associated with what? It is associated with low drainage density. That means what is going on over here? There's more infiltration, less runoff, and then also in terms of drainage density, we'll say drainage density will do what? Will be high. No, it will be low. In terms of drainage density, it will be low over here. And then if we're having heavy rainfall, we associated it with what? With high drainage density. So immediately when we associate it with high drainage density, that simply means now what is going on over here? There's more infiltration, there's less infiltration and more runoff. So immediately when the water flows on the surface, more water flows on the surface, that simply means now there's less infiltration of water over there. So these are the factors that influence the surface runoff, infiltration, and also drainage density. So these are some of the concepts, some of the aspects that you must understand in the final examination. And then now here are other examples over here. We're having the types of a rain, and then we're having vegetation cover, slope gradient, saturation of a soil or a soil moisture, and then we're having the last one, which is underlying rock. And then now the effects of human being on infiltration and also surface runoff and drainage density. We are saying here cultivation of the land, especially on the commercial landscape, loosen up the soil and then also promotes more infiltration. So that means if the soil has been cultivated, it loosens up the soil. Immediately when the cultivation is taking place on the soil, then the soil becomes loose. So that means now it promotes more infiltration. There will be more infiltration as compared to a surface runoff. And then poor farming methods also. It promotes high surface runoff as compared to infiltration. And then the urban expansion leads to creation of artificial surfaces. Artificial surfaces, they promote high surface runoff also. Because now remember, the water can infiltrate. It will flow on top of those artificial surfaces. Use of heavy agricultural machinery compact the soil surface and promotes what? High surface runoff and less infiltration. So I hope you are still following me, grade 12s. And then if you look at the structure, then we're having high density and also a low density. High density, what caused the high density, and also what causes the low drainage density over here. So we have already done that. We said we look at the surface here. There are some other aspects or factors that influences the way the streams are formed in the surface. Then the influence there is going to be high the drainage density, or it's going to be low drainage density over there. And then we're having types of drainage drainage patterns. The first one is dendritic pattern. So remember, immediately those rivers, after the formation of rivers, we say these rivers, they flow in patterns. So the first one here is its dendritic pattern. If you look at the characteristics of the dendritic pattern, we say it looks like branches of a tree. Tributaries, they join at an acute angle, any angle less than 90, and an underlying rock is a uniform resistant to erosion. And then the second one is trellis. The main streams are parallel to each other. Main stream joined by the short tributaries at the right angle. And then in terms of underlying rock, they say now they are found in the gentle sloping, alternating layers of the hard and the soft rock. That's where we get them. And also they are found in the folded mountains, this one. They are common in the folded mountains, the trellis. And then radial pattern, they say rivers flow away from a high central point, such like a butte or a volcano. It forms in an area where domes and also volcanoes occur. It is associated with a massive igneous rock. This is an underlying rock in most cases. And radial centripetal. And then this one, they say, if you look there, we are saying it streams flows towards the central basin, such as a marshes or a lake. In terms of the underlying rock, it is associated with massive igneous rocks. And then rectangular, tributaries join at the right angles and have bend of 90 degrees. In areas with hard rock that is well jointed. It's formed on an igneous rock that have many joints and sedimentary rocks with many joints and faults. So these are the drainage pattern, types of drainage patterns. Rivers, when they flow in patterns. That means now, in terms of this particular question over here, you must be able to identify a drainage pattern and also know the underlying rock. So when they say characteristics, how does it look like? How do you see it? So you must be able to identify it from other patterns and say this one is dendritic. It looks like branches of a tree. And then underlying rock is uniform resistant to erosion. If you look at the streams here, they are uniform resistant, equal or the same resistant to erosion over here. And then the trellis pattern also, the main river are parallel to each other. If you look at the streams here, they are parallel to each other. The main streams, they say they join short streams at the right angle. Here they are here. They are joining here at the right angle. Where do we get them? In most cases, you find them in the folded mountains, especially in the Western Cape. Most of the time, you get the fold mountains. And then radial pattern, it radiates. The river flows or radiates away from the high point to a lower point. So that means we find that at the high point over here, then let's say we're having is a mountain. The river will radiate from the high point going down, outwards, over here. Where do we get them? Normally where there's dome and also volcanoes occur. So it's an example then radial. Centripetal, they say streams flow towards the central basin, such as marshes or a lake, and then it's associated with massive igneous rocks. And the last one is rectangular. Rectangular tributaries join at a high angle and have bends of 90 degrees. If you check here, they bend over here at 90 degrees. If you look at this one again here, it bends over here at 90 degrees. Over here again, it bends at 90 degrees. So this is a rectangular pattern. And then now we'll move straight to stream order. Stream order, if we define it, we'll say it is a ranking of streams from the lowest to the highest order. Ranking of the streams from the lowest. If you look at 1 over here, it's the lowest. And if you look at 2, it's the highest. So that means now from the lowest to the highest order. So the first order, where a river starts, that's the first order. The smallest streams over here, these small streams, all of them, we call it the first order streams. All of them. Now, if I may make also an example over here. Let's say we're having a stream like this, streams like this. So this means this is a source over here, a source and a source. Where a river starts, it's a first order. And this side also, first order. Where they join, we say it's a what? It's a confluence. Remember here. Where they join is a what? It's a confluence. Where two rivers or two streams join, then we say it's a what? It's a confluence. So we are saying 1 plus 1 is 2 over here in terms of ranking the streams. So that means now if they say, maybe a question says must give us the stream order for these streams over here. It's a second order stream. Second order. Because it ends over here. The second order. And then now, let's make another example. Let's say we're having another stream over here, and then the other one there. And then we're having another one over there, and then another one over here. If you look at the two, they meet, and then they meet. So that means now, if then, we'll say this is 1, this is the first order over here, and the first order over there. If we focus on these two, we're saying this 1 plus 1 here will be 2. And then we'll say 1 plus 1 over here will be also 2. So that means now, in terms of the order of this particular streams over here, it will be what? It will be third order, because we'll say 2 plus 2 is 3. 2 plus 2 over here, it will be 3. Third order. Call it third order. And then the other one, you can make another example, it's fine. Let's make another example over here. So we're having first order over here, and first order. That means we'll say first order plus first order is second order. This one, first order plus first order over here, second order. And then first order and first order here, second order. And then first order is the second order. So that means now we'll say, start here. 2 plus 2, it will be 3 over here, third order. And then now look over here. So immediately when the high order, immediately when we're having 3 plus 2, the order remains the same over here. So the order remains the same. That means there will be third order over here. The order will remain the same. So let's look here. So that means now, here is it here. When the lower order stream and the high order stream join, they maintain the value of the high order stream. They make an example there. 2 plus 1 is 3. No, 2 plus 1 is 2. So that means now the order will remain the same, if only when the low order stream and the high order join. So immediately when they join, then the order remains the same. 2 plus 1 is 2. If you look over here also, you have been giving on how to calculate that. So 1 plus 1 is 2, 2 plus 2 is 3. And then 3 plus 1 is 3. 3 plus 2 is 3. Remember we said if the low order meet or join with the high order, the order remains the same. It maintains the value of the high order stream. So most people will say, no, in geography now, what kind of a calculations or of additions are these? But this is how we rank the streams over here, especially in the drainage basin. So that means this is how we calculate it. And then now, grade 12, let's move to the discharge of a river. Discharge of a river, we're having, that means this is a flow characteristics of a river. We're having laminar flow and also turbulent flow. Laminar flow, the river bed is level or even. And then also the water flows in a thin layer. It occurs in the lower course in most cases. And then also the velocity in the low because of gentleness of the slope on the lower course. It has a low rate of erosion, if you look at that. And then turbulent, also it occurs in upper course of a river. That is where now the river becomes, that is where a river is uneven, this one. So there's more friction that is taking place. And then also, if you look at the features that are formed there at an upper course, in most cases we say rapids and waterfall will form there at an upper course, if you look at this. So that means now, immediately when we are talking about, the river, the flow of a river, now we'll also talk about the graded and also ungraded. Graded profile and also ungraded. If you look at the graded profile, obviously we said the riverbed is smooth. So that means it's smooth or even. So it'll be like this. So this is what? This is the graded profile. So if they say you must draw a graded profile, this is how you draw a graded profile. If you look at the shape here, it's concave. And then we're having also ungraded profile. In terms of ungraded profile, it is having the temporary base level. It's having temporary base level over here. So that means now because of erosion, this part started being eroded over here. So that's why we are saying this one is ungraded. So that means the riverbed is uneven over here. But here, the riverbed is even. So that means this one is smooth. Can say smooth. And then also this one will say is what? Is rough. Smooth and rough. Graded, ungraded profile. So must be aware of that also, grade 12s. And then also, and now we'll move straight to, after the flow characteristics of a river, which is laminar flow and also turbulent flow. We'll move to longitudinal profile of a river, fluvial processes and landforms. Now, we'll look at that. Now, if you look at the two, we're having two profiles here. We're having a longitudinal profile, or they call it a long profile. So what is that? Let's look at that. They say this is a side view of a river from the source to the mouth. A side view of a river from the source to the mouth. So remember, we're having a river mouth. So that means we're having here a long profile of a river. Let's make it straight over here, straight. And then now, here is the source over here. Here is the mouth of a river. So that means we are saying it's a long profile of a river, side view. This is like a cross section. Eh? So it moves from, this river will flow from the source up until the mouth. So what will happen throughout the process? Then we're having the courses. A course. We're having upper course over here. And we're having a middle course. And then we're having a lower course. That means now, if you look at the upper course, we associated with it's a young river, young stage, or youth stage, and then this one is a mature stage, and then this one is an old stage. So that means now, this particular river over here, the water here, the velocity of the water will be high as compared to at the lower course. That's why we say old stage. A young person will run faster than an old person. Must remember that. So that's why we are saying in terms of the gradient, because the gradient is steep over here, the velocity will be high. But over here, because the gradient started to be gentle and flat over here at a lower cost, that's where now the river will start to flow slower as compared to the upper course. So now at an upper course, which features are formed there? Rapids are formed over here at an upper course. What else is formed over here? Waterfall is formed there. And then in terms of the channels, let's look at the upper course. Let's unpack this upper course. Let's unpack this upper course. So we are saying now, in terms of the upper course, we are saying what type of erosion that is taking place over here is vertical erosion. Vertical erosion is taking place over here. What else is taking place over here? So that means if we are saying the vertical erosion, then the channel of the river will be narrow channel. It will be what? Narrow channel over here. And then if you look at the shape of it, then we'll say it's a V-shaped. V-shaped. Because of the vertical erosion that is taking place. So the channel of the river there, the channel will be narrow, and then the shape of that particular channel will be V-shaped. And then the type of the features that are formed over here, features that are formed here will be rapids and also what? And also waterfall over here. So these are some of the things that will take place at an upper course. And then at the middle course, so remember the upper course, that's where a river is young and vibrant. Ne? It's having that particular energy because of the gradient. The gradient there is steep. So immediately when the gradient is steep, that particular river will start to flow faster as compared to the lower course. Now, in the middle course, the type of erosion that is taking place is lateral erosion. When the river erodes the sides of the valley. So this is where now we talk about lateral erosion. And then in terms of the channel will be wider. Wider channel. And then in terms of the shape, then it will be U-shaped. And then features that are formed over here. Spurs are formed. And meander are formed. These are some of the features that might be formed there. But meandering, remember, it will be formed especially towards the end of the middle course, where a river started to bend over here. So when we talk about meandering, that's where a river starts to bend. So immediately when that particular river starts to bend, that is when we are saying the gradient start to be gentle over there. And then the last course is the lower course. At the lower course is dominated by what? By depositioning. Deposition is taking place in the lower course. So, and then now, features that are formed over here. So obviously, if you look at the channel, there will be flat or, let's say gentle, very flat or very gentle over there. And then features that are formed there, there's so many features that are formed in the lower course there. Oxbow Lake might be formed over there. Braided streams might also be formed. Delta might also be formed over there at the lower course. Will also be formed at the lower course. Yeah, these are some of the features that might be features that will be formed at the lower course, especially when the gradient started to be gentle or starting to be flat over there. So let's go back to the fluid processes and look at that. If you look over here, Listen, longitudinal profile must know the definition. It's very important. Make sure that you go through the definition for longitudinal profile of a river. We said it's a side view of a river from the source to the mouth. It is concave in shape, if you look there. Now, if you look at the courses, here are they. Upper course, if you look at upper course, it's steep. And then fast flowing of a river, because it's a young river. Vertical erosion is taking place. The waterfall are formed there, rapids. Interlocking spurs also might also be formed over there. And then now middle course, gradual slope, slower flow, lateral erosion is taking place over there. Meanders, spurs are formed over there. If you look at the diagram over there also, it will give you a clear explanation of that. And then the lower course, almost flat, and then the water flows very slowly. Depositioning is taking place. So that means now the lower course is dominated by depositioning. And then features that are formed there, oxbow lakes, delta, meanders, and then we're having also marshes and braided streams. Sandbanks also, they are formed there at the lower course. If you look at the structure again here, look at this one, there's an upper course, it's a youthful stage. If you look at the gradient over here, it's steep. So that means this river or the streams over there or the water will flow faster as compared to over here. Now if you look at the middle course, we call it what? Mature stage. So in mature stage also, if you look at the gradient, it's starting to be gentle over here. And then if you look at the lower course, it's an old stage. So that means if you look at the gradient over here also, it's flat. That simply means now a river over here will flow faster as compared to a river at the lower course. Because of the what? Because of the gradient. That simply means now over here, the gradient is playing an important role here in order for you to understand the formation of features in an upper course, the formation of features in the middle course, and also at the lower course. Here is it also here, upper course, steep side due to vertical erosion. There's a high velocity of water there, and also narrow channel. Also associated with the turbulent flow. Low volume of water over there. Here's it over here, also middle course. We are saying also the valley is U-shaped. The river becomes wider due to lateral erosion. The flow is becoming laminar. It's associated with laminar. And then we're having a lower course over there also. It's very wider, and then lateral erosion also might be dominant there. But then most of the time, if you look at the lower course, we only talks about the depositioning that is taking place over there. Features that are formed there, meanders also, delta, braided streams, levees, floodplains, sandbanks, oxbow lakes, and we're having transverse or cross profile of a river. Here's it also over here. And then here are some of the examples. Waterfall, here's a waterfall over here. And then the benefits of waterfall, they attract tourists to the area. Remember what we said, the waterfall is formed where? It's formed in an upper course. It can also be used to generate electricity. These are some of the disadvantages also. Drowning because of fast flowing water over there. And then we're having rapids here. And then the most important thing about the rapids, they also attract tourists. And then also disadvantages, they are also there. And also having oxbow lake, the formation of an oxbow lake. So you must know that particular formation of an oxbow lake also is very important. And then if you look over here, step number 1, the erosion is taking place. And then now, step number 2, the meander neck becomes narrow. And then step number 3, neck cut off occurs. and then also the Oxbow or lake develops over there. So if you look at this one, if you can, I can demonstrate this one for Oxbow Lake. Let's look at that one for the Oxbow Lake. Now, let's say why the river start to meander this way. See now, so that means now what will happen to the water? Immediately when this particular river flows over here, it will cut the sides over there and deposit it in front. So that means this side will be cutted and then the other side will be the depositioning. Also, this particular water, immediately when it curves over here, it will cut the sides and deposit in front. So that's where now the neck of this particular river becomes narrow because of that. So after a certain period of time, you'll see then this particular river will move straight over here because they've eroded the part. And then now that means this side is a depositioning, and then the other side is a what? It's an erosion that is taking place. Erosion over here, and then this side will be a depositioning that is taking place. And then now, after a certain period of time, this particular river will flow straight over there. It will no longer curve over here because of the erosion that took place over there. So now, sometimes they will ask you a question. Let's say we're having the structure this way. And then they will ask you a question to draw a cross-section between A and B. Because this side is deposition that is taking place, the other side is an erosion that is taking place. That simply means now this side will be a slip-off slope this way, and then now the other one will be like this. See? So that means this one is a slip-off slope. Let's say water will be at this particular level. So that means you are having a slip-off slope, and the other one, this side, we're having cut-off slope. Slip-off slope, cut-off slope. So if you are saying must draw a cross-section from A to B over there. Great choice. And then now also, remember immediately when the Oxbow Lake, we call it an Oxbow Lake only if it's having what? This part over here, it's having water. Let's draw it again over here. If it's like this, and it will be having water, and then now, so that means if it's having water, it's an Oxbow Lake. So this part, if it does not have water, we'll say it's a meander scar. So it's a meander scar if it does not have water. But if it's having water, it's an Oxbow Lake. So the water now is moving straight, doesn't go on the other side because of the continuous erosion that took place over there. So that's an Oxbow Lake. And then also, here they are, and then here's a slope over here, slip-off slope, and then we're having an undercut slope or cut-off slope. So you could call it undercut slope or cut-off slope. Undercut or cut-off slope. And then braided streams are developed also over there. Natural levees also develops. And then also the other feature here is a delta. Delta, the definition for it is a triangular alluvial deposition at the mouth of a river. So remember, immediately when those deposited materials accumulate inside a river or an ocean, that's when now, in most of the time, you'll see it will create an island of distributaries here. So that means that particular island, on top of it will be having some streams. These streams over here, we call them distributaries over here, on top of that particular island. So that's where a delta is formed. At the mouth of a river, that is where a delta is formed. That's why they say here, where where delta formed at the lower course, yes, of a river, but where specifically? At the mouth of a river. That is where this particular delta is formed. And then condition necessary for the formation of a delta, there must be a large amount of sediments. A sea must have a weak current, not a fast-flowing one, so that the materials must be accumulated inside a sea. And then small tidal range, and then also the speed or velocity of the water must be decreased. That means that particular sea must flow slower, rather than, if it's flowing faster, it will erode the materials, but it must flow slower. The benefits of a delta, very important. Make sure that you go through them. They contain fertile soil and flat land for farming. And then also, why are we saying fertile soil? Because remember, a silt, inside that particular water, we're having silt. The silt is the one that will make the soil fertile. And then for aquaculture can be practiced also, such as fish and also the prawn farming. More water for domestic and agricultural purposes. Tourist attraction also. Good transport links and good for trade also. There are also some of the disadvantages of a delta. Hard to transport, hard to make a transport link by roads because it's expensive to construct bridges over there. So it's going to be difficult for you to construct it. It will cost a country a lot of money to build that over there on top of the delta. Deltas are constantly flooded also. Not good for establishing settlement. And then also mosquito bite causes malaria. Storm siege occurs also. So these are some of the disadvantages of a delta. Great jobs. And then here's a summary of the longitudinal profile and transverse profile. Transverse profile, the shape of a river, vary from one bank to opposite bank. And then here is a summary of it. Here are some of the features over there. We talked about this one, which is an oxbow lake. We talked about meander, braided streams, sandbanks and marshes, and also the delta. Also, we talked about the whole thing over there. And then the other one, it's a river grading. Also, I did talk about that when I was explaining the flow characteristics of a river, where we talked about laminar flow and then also turbulent flow. So here's a graded river profile. If they say must draw that, this is how it looks like over there, concave shape. There's no temporary base level over here. But if you look at this one over here, it's an ungraded profile. There's somewhat temporary base level of a river over here. See, there's a waterfall. Also, there's a lake over here. So those, and then yes, and then we're having a base level of erosion, which is the lowest level to which a river can erode. That's a base level of erosion. And we're having types of base levels, which is the temporary and local base level and ultimate or permanent base level. Permanent base level, it's a sea, inside the sea. That's a permanent one. The lowest point in which a river can erode is inside the sea. Yes, and then the last part, just to wrap up, the river rejuvenation. It is a process where a river regains or renews its erosive power and begins to erode vertical. When the river regains energy to erode again, that's another definition that you can also use. It's a new cycle of erosion. So we're having 3 definitions there. Any one of those, correct. And then causes or reason for a river rejuvenation. Uplift of a land due to a thermal movement such as isostatic uplift also can cause a river rejuvenation. Can cause that particular river to start to flow again. Increase volume of water as a result of river capture. High rainfall increase the erosive potential of the river. Sea level drop also. It's one of the reasons why the river rejuvenations occurs. And then landform associated with the river capture, it's a nick point, especially at the waterfall. Terraces also, inside meander. Here's a picture over here that will show that the nick point waterfall. Nick point, it is referred to the point where old erosion level meets with the new one. That's a nick point waterfall. Because the old one, it will meet with the new one over here. So the old one is up here, here's a new one over here. And the waterfall basically formed when there is a sharp change in the gradient. That is where, in most of the time, the waterfall formed where there is temporary base level. Here is the example of terraces. Here they are over here. And then there's a incised meander, an example of that. And then the last part, stream piracy or river capture. It's when one river steals or robs the water of another river. When energetic stream cut back or intercepts or steals the water from another river. If you look at the two pictures here, it will give you the clear understanding there. Before capture, and then we're having another one after capture. So that means now, if you look here, if you look at the characteristics of these two rivers, the other one's flowing at the lower level, the other one's flowing at the higher level. So if you look over here, here are the characteristics of the river. The other one is flowing at the lower level, and then the other one's flowing at the higher level. This one is less energetic. This one is higher, is energetic. So this one is flowing at the lower level, lower lying area, or lower level. This one is flowing at a high lying area. That's why we are studying it. Or how come this one flowing at the lower lying area capture this one flowing in the high lying area? So this one is slow flowing, this one is fast flowing. This one is less erosive, this one is more erosive. Flows on the softer rock, this one flows on the harder rock. High lying area, this one at low lying area. So that means this one will capture the other one. But then if you look at the features of the river capture, a capture stream is a river that steals the water of another river. A river that steals the water of another river. And then a captured stream, also a river that has been stolen, and then that its water has been stolen. And then elbow of capture, it is a right-hand bend or point where a river capture took place. A wind gap or dry gap, a dry river, valley with gravel, and then we're having misfit stream. Refers to the streams that have too little water for the valley within which it flows. And then the effects on the settlement, what will happen to the settlement over there, especially after the river capture. They will be reduced in terms of the water for domestic use, less water for generation of electricity, and then poverty will be increased, higher unemployment rate will also increase over there. Grade 12s, let's prepare accordingly for the final examination. Let's make sure that we go through our work properly, especially geomorphology and climatology. Go through them, study them. This is the only opportunity for you to write grade 12. Let's work harder in preparation for the 3rd of December, which is the final examination for geography in 2020. Let's make sure that we study harder. Don't sleep without studying. Good luck with your examination. God bless.